Hi, hope everything's going well for you today. When we have a sub, we'll always have some video like this, and the purpose of this is just to help everything keep moving with the pacing that we have. And so what you'll do is you'll answer questions in the Edpuzzle you go through, and then also you need to have your notes out. So you should have your notes out right now, and you're taking notes just like you would if I was here in class. Today we're going to be talking about classifying matter. So when we talk about matter, anything we see, a desk, a chair, all of that is matter. But then what type of matter is it? And so you can see from this chart, we're going to really separate into two different categories, two different main categories. One is pure substances, and then the other here's pure substances, the other is mixtures. And so we'll go ahead and talk about those and then how to break it out from there. Now you want to get to where you have this whole chart down, okay, so that you can draw this yourself, okay, and we'll even put a little bit more detail in this as we go along, but you should feel comfortable with this. All right, so the first part is pure substances. Pure substances are substances that cannot be physically separated, okay, and when we say physically separated, what we mean is separated by something that doesn't require a chemical reaction. For example, a physical separation would be if we took water that has salt in it, okay, so we've got salt water, and if we evaporate off the water, evaporation is a physical process, so we could separate the water from the salt without any chemical reaction. So that means salt water is a mixture, okay? On this slide, we're not talking about mixtures, but instead we're talking about pure substances. Pure substances can't be separated like that. We can't put them through a filter to separate them. They are sort of locked together unless we carry out a chemical reaction. So the first type of pure substance is elements, and elements only have one type of atom. And what I mean by one type of atom is essentially if you look at the periodic table, which I know we haven't talked a lot about, but if you look at the periodic table, it is each of those letters on the periodic table is referring to an element. So we would have oxygen can be an element, and neon, and helium, and carbon, and most of these are things you've heard about in the past. Okay, now the key is when it's an element, it can only have one type of atom, so only one of those boxes on the periodic table. Now, there's a clarification though. When we have a lot of the times, the elements will come in a form where they have more than one together. Okay, let me clarify that. More than one of the same atom together. So an example of that is oxygen, which always comes in a pair. Okay, so you always have two oxygen atoms bonded together. Again, it's still an element because it only has one type of atom. They're both oxygen atoms, but they are bonded together. And this is what we call a diatomic element. And some elements even have more than two, that whenever we find them naturally, they always have like two bonded together or three bonded together or something like that. But oxygen's a great example where the pure element of oxygen is O2. Then, of course, we have helium. Helium only comes in single atoms. Okay, and that's common also where when we talk about pure helium, it's only helium atoms. All right, now we go down to compounds. Compounds are discussed more here. Let me kind of move my picture out of the way a little bit. They're more, I don't know if that even works, so let's try this. We'll, one second here. Yeah. Anyway, compounds are going to combine more than one element. So you're going to see two different letters, like a famous one is H2O. Another famous one is NaCl, which is sodium chloride, and that is table salt. And then another one that is pretty well known is ammonia. It's used as a cleaning equipment, and ammonia has nitrogen and hydrogen. Okay, and this is a little off on how they show it, but nonetheless. The point, though, is these compounds have two different elements, but they are bound together, and so they have something called a definite proportion. So it's not like you can have H2O, that's a different mixture. It's not like we could say, hey, let's have some H3O. That's totally different. That would not be H2O. That's a totally different compound. So the pure compound of water is two hydrogens and one oxygen. All right, so quick question here. Are these an element or a compound? What I'll do is I'll have you answer in Edpuzzle there. So go ahead. All right, we're back. This is going to be obviously an element. This will be a compound, though they screwed this one up. Hopefully you can tell they really screwed this one up because it shows HO2 instead of H2O. So they did not do a very good job of showing it, whoever had that one. And then the next one, O2, is a element. So we've got an element, a compound, and an element. All right, so now classifying matter. So we have, again, we start with matter, we have pure substances, we have elements and compounds. Now we're going to be talking about mixtures. Okay, mixtures are when we put two pure substances together to form a mixture. Okay, and so the key is that mixtures can be separated by physical methods. Okay, and one key too is that they can have different proportions. They're not always the same proportions. Like H2O is always 2 hydrogens, 1 oxygen. Whereas mixtures, you could have, just like with Kool-Aid or something like that, you could have strong Kool-Aid or weak Kool-Aid. And so mixtures can be all different proportions, and that's how those work. Okay, so here's the two types of mixtures that you'll need to know. One is called homogeneous. Homogeneous mixtures are ones that are even throughout. Okay, and so it's just easy to remember this as like evenly mixed mixtures. Salt water is a great example of that. So is Kool-Aid. Kool-Aid, you know, you mix it. It's if you mix it well, of course, then it's going to be even throughout. You could try Kool-Aid. It's like, oh, I could take it from the top. I could take it from the bottom. It would all have the same amount of sugar versus water. Okay. Now we also have something you wouldn't expect, but that's something called alloys. Alloys are when we mix two metals together, okay? So this is something you wouldn't normally think of as a mixture, but that is a mixture, just like Kool-Aid's a mixture, but it's a mixture of two solids. And alloys have some important purposes, like steel, for example, is an alloy. Like this is probably, this is up here at the top. This is an example of steel, and it shows carbon and iron together. That makes the metal much stronger by doing that. Okay, and then we have, after homogeneous, which is evenly mixed, so homo means same, and that means same throughout, essentially. Then we have heterogeneous. Heterogeneous starts with hetero, which means different. So it means that it's different in different parts, essentially. So good examples of that would be a heterogeneous mixture would, especially a good example would be like dressing, where you have oil and water. They're not evenly mixed, okay? And then even like whole milk is kind of like a heterogeneous mixture, because there are kind of, if you go down to the microscopic level, you would see there are big chunks in different places and different things like that. Okay, and let me just clarify on heterogeneous mixtures. These are what milk is. Milk is considered to be a colloid because it has these larger particles. So when they have larger particles like that, like the proteins in milk, but they stay floating around. They don't fall out over time, like maybe orange juice might or something like that. But the big important key is this: heterogeneous is not evenly mixed. So salad dressing would be a great example. And then another example might be just like sand water, sand and water. You shake it up and it's not going to be evenly mixed. So pond water, all of those things would be examples of heterogeneous mixtures. One other word we haven't really defined here is suspensions. Suspensions are things that you have to shake up, and when you shake them up, they stay relatively evenly mixed, but then they fall out over time. And one example of a suspension is if you have like a shot you have to get at the doctor's office. A lot of times it'll be in suspension, meaning it has to be shaken up before they give you the shot, essentially. So, all right. So now we're going to review here the pure substances and mixtures. Now, I'm going to tell you, this does get a little bit tricky. So you want to get to where you're comfortable looking at these types of images and saying whether these refer to pure substances or mixtures. Now, I know this is a good idea because I know this is going to show up on the test. Okay, and so that's why I'm emphasizing it. So a little red bell. This will be on the test. Make sure you're aware of that. All right, so let's go through. I'm going to just, let's have you go through and look at these. And the way you want to look at these is you got to say, okay, each dot is referring to a different type of atom. Okay, and then some of these are bonded together into compounds. Some of them are just pure elements. And so I want you to go through and try to classify each of these as elements or compounds. And my picture's probably in the way on one of these. Let me see if I can get it off. Okay, well, anyway, try to go through and get those right, and then we'll go through them ourselves as well. Okay, so hopefully you had a chance to answer. And by the way, we're not going to get too strict on the grades on this first one, so don't get too worried about that. All right, a couple things to take note of. First of all, this first one here, number 1, is going to be an example of a compound because you've got two different types of atoms, and it's a pure substance because every one is the same compound essentially. So, Okay, the second one is going to be a mixture because you have two different types of atoms that are not bonded together. These ones are bonded together, these ones are not. So this is a mixture. Third one is going to be an example also of a mixture because if you look, you have a compound mixed with a pure element. The fourth one is going to also be a mixture because you have two different compounds mixed together. The fifth one is going to be a pure element, and the sixth one is going to be a pure compound. And those are going to be the different categories. Okay? Oh, sorry. All right. So there's that nice video at the end that you can check to learn about how to categorize these. So take some time to figure out those categories. You do essentially need to memorize that chart. So that chart that you saw at the start, you want to get to where you've got that down. You can categorize whatever you see, and that'll help you to get ready for that unit test that we'll probably have coming up next week. All right, well, good seeing you guys. Hopefully you guys have a great day, and be nice to the sub. Really, really important. Have a great one. We'll see you. Bye-bye.